everybody. Welcome back to Modern Web Platform. I'm Jeremy Foster. You guys probably know that by now.
With Michael Palermo. I am so excited for what we have in store for this module. I promise you, you are going to think the world of what we're going to be doing.
There were a whole bunch of references in there. I'm not sure. I caught 3 of them, I think. So we are going to be looking at core APIs. This is basically a JavaScript discussion. I mean, kind of. It involves HTML and CSS to some degree, but a lot of what we are going to do here is going to involve JavaScript. So that's just kind of the way that you interface with APIs. So let's take a look at the module overview, at all of the different aspects that we're going to be looking at. So as my colleague mentioned, we are going to be looking at promises. We promise, and we promise no more promise jokes, no more promise puns. Then we're going to look at web storage, aka local storage. It's another part of the HTML5 standard. It's been really helpful to have some storage in the browser, and Michael's going to tell you all about that one. And then back to me, we're going to talk about indexedDB, database in the browser. WebSockets in the browser. Everything's in the browser now. It's crazy. Web workers, multi-threading in the browser, and geolocation. So figure out where you're at, and you don't have to worry because it always asks, are you okay with this? Are you okay with the browser knowing exactly where you're at? So you got to make sure your users feel safe when you're doing geolocation. So these are the topics. Let's go ahead and dive right in. The first one is promises. Promises are one of these cross-cutting concerns. What I mean by that is that all throughout your application, you're going to be utilizing promises, okay? Because a promise is quite simply a pattern that implements asynchrony. That means that you're going to be able to do things like start this process and then go about doing other things, but when that process finishes, then I want to do something in response to it, something that's kind of dependent on it being finished. So that's asynchrony, and one of the points of confusion is between asynchrony and concurrency. And at first it kind of seems like they're the same thing, you know, but not at all. Concurrency is really, or at least virtually or apparently, doing 2 things at the same time, okay? Throwing it up to the operating system or to your framework that you want both of these things to work concurrently, and then the operating system managing the utilization of multiple threads to make these happen apparently at the same time. I mean, they really don't happen at the same time. I guess there are some things that can happen at the same time if your processor architecture supports it, but for the most part, you know, we're talking about switching between threads here. That's concurrency, and it's really helpful, but we're not really talking about concurrency until we get to web workers here in just a few topics. With promises, we're simply talking about asynchrony. So we're talking about capturing that moment in time that something you've requested to happen is done happening, okay? It becomes really important in course 2 that we're starting tomorrow when we're going to be talking about universal Windows apps, development of universal apps for Windows, because a lot of the API, the core Windows API, is asynchronous. That means you might call a method saying, ask the user to take a picture with his webcam, and when he's done, then I want to do this. So those are all asynchronous methods. Those become really important. So yeah, hope that's clear. Let's go ahead and take a look at a demo in CodeShow. Now, I have the promises demo in an unfinished state. So the one that I'm going to open right now is called Promises Concept, but when you download it, you'll just use promises, and that one should work for you, even though I'm using Promises Concept right now. So before I run through the code, let me show you what this does in the demo. You can see that I have 3 sections here. I have this long sync task, I have this long async task, and finally I have this long async task using a promise. So the long sync task, this is a synchronous operation. This means start something and block the thread until such time as that thing completes. It's fine for something that takes 5 milliseconds, but if this thing might take a few milliseconds, you can't do that. If you do that, you'll end up with a user interface that's patchy. It's jumpy, it's laggy. The user just really, really hates that, especially in this day and age when they're used to everything being really, really smooth. So a long sync task is going to block the UI, and the thing that I want you to notice when I run this is that the button is going to stay in its hover state. It's going to stay dark, and we're going to be completely blocked. Right after I hit this start button, in fact, I'm going to try to hit back in my browser. So start, notice that's black, and I'm hitting the back button and nothing's working. Oh, and then finally after a few seconds, it works and it goes back for me. That was a block of the UI. It's really terrible for me to hit something and then try to do something else and have this feature blocking me, okay? So we want to stay away from that. Now let's look at what this looks like if I do it asynchronously. So in other words, when the user touches this button, do this 3-second operation, but do it asynchronously. Ready? Start. Now notice that that bar completed right away. Let me do it again. Ready? Start. That bar goes right away, which is kind of a lie. It's saying, I'm done.
Very deceptive.
Yeah, it's deceptive. It's not done. It's not blocking the UI, but it's saying, I'm done right away, and it's not done. So go ahead.
So we can implement this if we really do want to be deceptive with our user.
Yes, absolutely. If
Okay.
you want to trick your user, yeah,
Okay.
you could do. There are a variety of methods for tricking
But
your
if we
user.
want to be honest, what should we do?
Yeah, so what we want to do is still be asynchronous, so not block the UI, but we want to use a promise because that's going to allow us to, once again, capture that moment in time when our task completes. So this is the same 3-second asynchronous task, now using a promise, so watch when I hit start. Not only does it tell me when it's finished, but it's able to tell me intermediate steps on the way. So
Very
promises are really rich. It can come back afterwards and say, I'm done, and it can report during the process and say, hey, I just finished 30%, 50%, 99%. Don't you hate it when you're doing something and it says 100% complete, but it apparently is still working? And you're like, hey, you say 100% complete, you better be done.
That's right.
Yeah.
Yeah.
A little pet peeve of mine. Okay, I'll reset those, and now let's go look at the code here. The HTML is nothing special. We don't even need to look at it. The CSS, also nothing special. Almost everything's happening here in the JavaScript for this one. So at the bottom, we have this long async task, and then we have this, synchronous task, and then we have this long async task. Now, in order to do the synchronous task, I basically just do a while loop for 1,000 milliseconds times whatever second delay we're interested in. In this case, I've got it programmed, configured for a 3-second delay, so it's going to do a while loop for 3 seconds there. While loops are blocking, okay? It is processing it as quickly as it can. It's running this loop as quickly as it can, and it's completely blocking the thread. Now, the long async task is a bit different. This is using the window.setInterval and saying, I want to run this function with 1 second gaps as many times as we have seconds delay. So once again, 3-second delay. So it's going to call this 3 times and use that gap, that interval, and essentially wait for 3 seconds. But the setInterval method in JavaScript, that's just a method in JavaScript that's built in. setInterval is not blocking. Neither is setTimeout, okay? These are concurrent tasks. This is the way that before the prominence of the promise pattern in JavaScript, there was setTimeout and setInterval. That was our way of doing concurrency, and callbacks were our method for doing asynchrony, okay? Now there's one more method here, and that is the long task async promise. So this is another asynchronous task, but this one is returning a promise. Okay, it's actually creating a new promise, and I'll show you about this pattern here in just a second. It's creating a new promise, and then it's still doing the setInterval, but it's not saying that this promise is complete. In other words, it's not resolving the promise or completing the promise until that interval loop is done, until all of those intervals are done. Okay, so that, and then actually in the function there, in the middle of it, for each interval, we are reporting out progress by calling this special method. Okay? I hope that's clear to everybody. And what that ends up doing in each of our examples here is taking this simple progress indicator and changing its value whenever the user clicks on it. So the Long task sync is calling long task sync. We're calling long task async. And then we're calling long task async promise. Now there's one thing that's different about long task async promise. Notice with the synchronous, we just call it. We just call this function, right? With the async, we simply call this function. And afterwards, we do our update of our progress bar. But with the promise pattern, we're calling our promise, or we're calling our method, and then look at this fancy function here, .done. If you have a promise, it implements the if you have an object that implements the promise pattern, it will have a .then and a .done. They're subtly different, so for the cases of discussion, we can consider them the same. But this is my opportunity to specify a function that I want to run whenever this function completes. No matter how long it takes. It might take 3 seconds in this case, or it might take a minute or two. And I want something to happen whenever this completes. And so I have the opportunity to do that by specifying the done function. So notice that for done, I'm passing in a null, and then a function here. And this function is going to give me an opportunity to update the progress, and it's also going to give me an opportunity to update when the whole thing is complete. Yeah.
And probably good to mention that when you see in code show, there's times when you're going to see querying for things in the HTML with just a queue. And when you see that, that is a custom method that Jeremy wrote that essentially allows us to do it without having to say document.get all these other things.
Yeah,
so, you know, that queue method's in there. And I think it'd be cool if you could just show in your code as well that function really just maps to that P that was in the down below.
Oh, for the promise?
Yeah.
Yeah, absolutely. Yeah, and actually the queue has been a point of confusion in code show. It's really helpful, but I get a lot of questions, people saying, what is the queue for? And so instead of defining it globally and using it in all the demos, if it's helpful in a demo, we're going to include it right there in the demo. So kind of all of the code goes with the demo, so you feel like you have everything you need right there. In this case, the queue is defined globally, but that won't be normally done.
Right.
Okay, so yeah, the synchronous and the asynchronous are straightforward. That's just kind of the way JavaScript works. But what I want to really show you here is this asynchronous promise. Now, we're talking about creating a new promise. So we're talking about creating a definition where we're determining when our function is done. We're creating for ourselves an asynchronous function. If you're just consuming an asynchronous function, that's very easy. Somebody gives you a function name, like if you're calling into the Windows RT, maybe you're calling the capture file async from the capture, what is it, windows.capture.ui.capture settings, or camera capture UI.
Sounds good.
Something like that. Inside camera capture UI, you have the opportunity to ask the system for a webcam shot, and it's asynchronous. So you just call into it, and then all you have to do is say .done. In this case, we ourselves are defining a function, and we want to make it asynchronous.
Yes.
Okay, so we say, I want to return a new promise. That's what we have here, return a new promise. Okay, we're defining this promise. Now, when you create, first of all, we're using the promise implementation in Win.js. There are about 75,000 promise implementations now. Many of them are following the original Common A pattern for promises, which is a good idea, including the Win.js pattern. But there are a lot of them out there. There's jQuery has deferred. It doesn't quite follow the Common A as far as I am concerned. There's Q, which is a really popular and light one. That's quite nice. There's an example of using Q on my CodePen if you'd like to see that. Here, we're just using the Win.js promise because we're in a Windows 8 app and it's available to us. So I'm creating a promise, and in the definition of that object, it wants a function. It wants this function right here. And this function, when it's called, is going to be given 3 things. It's going to be given 3 functions. So this function is going to take 3 functions. And what we're going to, oops, I lost my JavaScript there. Let me reopen it. Don't know what happened there. Okay, so the promise is expecting a function, and that function is going to receive 3 functions, and I'm just going to give them names. I could give them their full name, but in this case, I'm going to be terse about it, and I'm going to call them C for complete, E for error, and P for progress.
That's good.
Yeah. So the C for complete is a function that we get to call whenever we want to say, all right, done. It's been 3 seconds or whatever, but we're done. We're done with the calling of this promise. The E is our opportunity to say something went wrong. We get to define that. So we get to say, you didn't pass a parameter in right, I tried to contact the internet and you don't have a network connection, the database has a problem, whatever. We get to come back to the caller of our asynchronous method in the form of this error function. And we get to pass them back as much information about that error as we want, so it's really helpful. And then the third parameter that it's going to pass into us and that we get to utilize in the form of a function is what we're calling here P, and that is the progress. So we get to essentially report out progress by simply calling this P function. Okay, so those are the 3 things that a Win.js promise needs in order for you to define its implementation. So you can see that we're doing a loop that is happening, in this case we're doing 3 seconds, and so it's going to happen 3 times. And for each of those we're going to call P, and we're going to set the number of seconds that have elapsed. So P, we're going to pass 1, and then 2, and then 3. And then when we're all done, finally we're going to call, in other words, if we have reached our max delay, then we're done. So we're going to call C. Now, when you call C, this complete function, you have the opportunity to pass a payload back. So promises not only say you get to do something whenever this function completes, but they get to return something at that time. So that question of are you done yet comes with a parameter, if you want to use it, that is the payload of that promise. So in this case, there isn't one. We're just calling C, we're done. But if we wanted to say we're done and the answer was 74, we can pass that back as a variable. So that is the implementation of a promise. It ends up looking like this, where you get this great user experience where you get to say go, and then you get reports back, and then it gets complete. So that's promises.
That's cool.
It's a really important concept, but actually if you want to be really simple about it, all you really have to do is remember that when you're calling into a popular framework like WinRT, all of the methods that are asynchronous are going to end with async. So it's capture file async if it's an asynchronous method. That one happens to be. When you are creating your own methods, even just in your own application, I highly recommend that you follow that pattern and call all asynchronous methods with async, because then the caller knows this isn't going to return to me the number 74. It's going to return to me a promise, perhaps carrying the payload of 74. All right.
Cool.
So that is the concept of promises. I hope it's clear. Go check it out in Code Show. Remember to check out the demo called Promises, even though the one I was showing was called Promise Concept. And over to you, we're going to talk about web storage, right?
We are going to talk about web storage. This is a very cool thing to talk about. In fact, I'll go ahead and synchronize with that too. So, web storage is... in fact, if you could move it over to my screen so it's synced with me.
You are.
Good.
Got it.
So kind of like what I did earlier today, what does the source, the standard say? Yeah. This specification defines an API for persistent data storage of key value pair data in web clients. I think the simpler way to say it is you could store data locally on a device via the browser or an app. That's it. And you have 2 options available. That's why it's really under web storage, not just local storage, because local storage is for persistent data and session storage is for data that you only want available while the browser or the app is on, basically. And once that shuts down or once that session is over, then that data is gone. So it's really your way of saying, I'll use my local storage if I want that data to be around and it doesn't expire, or I will use the session one if I just need to have some some temporary data while this session is open, and I'll only keep it for that. Now, what are the advantages? That's the cool discussion. And if you're a web developer right now and you don't know about this, I want, if you could brace a chair or whatever you can do, I want you to think about this. How we've had to deal with data, persisting data associated with a user or a session has been quite a feat, especially in the early days of HTML and some of our server-side technologies married with our client-side technologies. And I'll give you some examples. I want you to think about these. If you're a web developer, think about how much do you love cookies? I mean, do you love cookies, Jeremy?
I love cookies, but I also hate cookies.
But he also hates cookies. How much do you love form data, posting all that stuff back and forth? How much do you like putting your data right into the query string? That's so much fun.
Especially hidden form fields for the purpose of persisting data always felt like such a hack.
Yes. So if you are hearing all those things and you're like, is there yet another way? That's what we're talking about. And it's so good. And here's why. Let's look at those advantages again. So first of all, the data that you're storing, it's all happening on the client. That means there is no transferring of data going back to some server and then round tripping all over again. And the more data you have, the more that, took up bandwidth.
Traffic.
Then, because we're storing it right there on the device, you can store larger amounts. Now, that's only restricted by the kind of device / or I should say browser or app. They all have different maximum amounts. The minimum is 5 megabytes. But other user agents might be more lenient and say you can have more than that. Or if it's an app versus a browser, you might have some different storage size. But you're going to get more than you can with just a simple cookie, or with what's available in the query string. Now, form data, yeah, you can post back and forth. But again, that's all HTTP traffic that's unnecessary. So all the supported browsers, all the current ones, all support this.
All the cool ones.
All the cool ones, you should say. Meaning, if you're targeting the modern web, which is what this whole day is about, then you'll be very happy to know that this is one of those things that is supported across all of them. That's really, really cool. So you can go to your Can I Use or wherever, and you can go validate this on this local storage and session storage. So we're going to right now take a look at a demo, and we're going to showcase how this is going to work in a couple of environments. I want you to see it work in 2 different environments. We've been talking about, well, it can run in an app or it can run in a browser. I want to see it run in both. So that's what we're going to do right now. I'm going to move over to, the first one is, we're going to see how this works in a web page. This is on CodePen. So I'm going to click on this one here, which is the web storage, the demo of local storage for MVA.
So people have access to this. They just go to your CodePen, right?
Yes. Yeah. If you're just signing in for later today, meaning you weren't here earlier, you just go to this URL at the top. And specifically, if you get to CodePen.io Palermo 4, then you can go to /pen, then the CHBQG. Or just, once you get to Palermo 4, you can probably find it visually. So let's first of all talk about the HTML that's involved. This HTML is simply saying, I want to have a header that is our main display. That's, by the way, this thing here where it says no words found in storage. And you might be wondering, well, since I don't see that up here, how did that get populated? You're going to see that in the JavaScript in a second. We have our horizontal rule. That's this down here. Words to remember, and then I'm supposed to type in some words to remember, and then we're going to have a save and a clear button. So I'm now going to move over to the JavaScript side and showcase that in greater detail. First thing you'll notice at this JavaScript is I've declared a variable to represent all of the elements on that page. So I have the save button and the clear button. The words that I'm going to be typing into that text box, that's what this is representing, and the output or the display. The first thing I do is call show words. It's a function that I created down here. That's where this no words found in storage appears, because it's saying, hey, let me check my local storage, and let me check for the words in local storage. it's going to give me what that value is, but this double pipeline, wonder if Jeremy might know what that means. What does a double pipeline mean in JavaScript if I'm saying, hey, give me what this is, but then I have this thing here? What's that really saying?
I think that means or.
It is an or, but in this context...
Bitwise or.
Yeah, it's going to basically say, hey, if you're in local storage and this returns a null because there's nothing there, or if it's undefined, then it will give me this as a default. So for some of you that are in other languages where I think this was accomplished in C# with like a double question mark, you know, where you could say, give me this, and if it's null, then give me on the other side of the double question mark. I think that's called the
coalesce.
Yes, the null coalescence operator, if I'm saying it somewhat right. So that's kind of what this is in JavaScript when you have this double pipeline.
And I was mistaken when I called it a bitwise or. It is actually just a plain or. It's just that in this case, it's used to do what you're talking about.
Because of how JavaScript interprets it, because of how this renders as either undefined, null, or whatever.
Yeah.
So now that means, so we know what decision it made. It apparently found that this was lacking. So it says, well, since I found nothing there, I might as well just put this no words found in storage. However, if something was there, it would have displayed it because it would have taken it from here. So let's see it in action. I'm going to go to this words to remember, and I'm going to put in Kilroy was here. Those are some words to remember. Oh, maybe I'll change that to Barney was here. I don't want this to be associated with anything other than just my random imagination. So then Barney was here, and I'm just going to say save. Now, when I click save, let's go follow this up here. The click event says go to local storage, and for words, take the value of whatever was put in here, which was Barney was here, and then let's go show words again. Now, when I went to go show words, apparently there was something here, which is cool. Now, I'm going to close this page. I'm going to go back and go to codepen.io, and I'm going to click on my profile, and I'm going to go back into the MVA Modern Web Platform collection, where I will find, you could even see it in the little screenshot, Barney was here, even before I click on it. But I'm going to click on it again, and you're going to see that it, even though I closed the page entirely, it still has that information. Where did it store this information is what's fascinating. So I'm going to talk about this one. This is exciting. It stored that data locally according to however the browser wanted to store it. But the key thing is that it stored it wherever the browser put it, was able to retrieve it, and the only thing that can retrieve that data is this page. That call, that's it. That's or I should say, this application or this website with the code that I'm using to execute it from my domain is able to access that particular data. But it's not doing any round trips to any servers, and it's only going to be used when I use it. And I know that kind of sounds funny, but in the old classic HTTP world, we had data going back and forth that we never even needed sometimes to go back and forth, but it was just there just to keep it alive. We don't need to worry about that here because the data is just stored locally. It is so ridiculously easy to use, and it outweighs all the other ones dramatically in terms of benefits. So if you're not using it, and you're thinking, well, what if a browser doesn't support it? And I'd say that's a fair thing to say. Then I'm going to show you another little thing that you can do, and I'll expand this out. You'll notice that here I use this double ampersand. So why would I do that? The answer basically is this. If you see something appear here, and then another thing appear here, and you see the double ampersand, what you're really saying is, if this is true, then you can do this side too. But if this is false, don't even bother doing anything on the other side. That's crazy. But you know what it is? It's a very quick way to do feature detection. That's basically what we're doing. We're saying, if local storage exists, then I'm going to use it. Now, I could have done yet another ampersand on this side and said, ampersand local storage remove item, and then ampersand, ampersand, and then actually make the call, because I could have confirmed that remove item also exists on it. But I'm just giving you an example of how you could do a really quick check to do a feature detection. And I'm saying in at least the clear event, I'm saying remove the words. And of course, I guess I didn't bother to be that safe with the save event, but I should have.
Well, I think you'd be pretty safe because I just looked it up for you, and apparently only Opera Mini does not support local storage.
That's good. So with that there, I think hopefully I didn't just ruin everything with what I just did. Let me do a save and go back and come back into it again. I'm pretty sure that will be the wrap up. Where is it over here? One more. Oh, no, I just saw it. Let me go back. There it is. So it's loading it up. Maybe it didn't. Oh, there it goes. Words to remember, so I'm going to say haha, because I think I made a change. Well, I think I may have added an error on that. So I'll digress. I'll say, you know what? That was all I had on web storage. I don't want to have everybody troubleshooting what I'm doing because I think you have the next topic.
Okay.
Why don't we go over there?
And you know what? The next topic is a little bit related. It's you talked about local storage, which is the ability for the browser to store information about that site. Did you just figure it out?
Yeah.
Okay.
I'm sorry.
Yeah, no problem. So the local storage is the ability for the browser to remember things, just kind of like free-form stuff, whatever you want to put in there. It doesn't have to go back to the server and come back. A lot of advantages, like you mentioned. And what I'm going to be talking about is indexedDB, and that's pretty much the same concept, except instead of just a little storage area where you can drop an object or another object, and you kind of need to know the names of each of those objects, indexedDB gives you a local database. And the big advantage to a database is that it can be queried. So for instance, instead of just go get the thing called words like you did, I would be able to say, look in my words collection and find the one that matches Barney or something like that. So essentially, it's a database in the browser. No lawyer speak here. This is just the plain and simple. It's just a database in the browser. It does allow for this client-side data storage, but also this retrieval by way of querying. And I'm not going to spend a ton of time here because conceptually it's pretty similar. But I do want to take you to a demo on HTML5 Rocks, which is a really great website. And if you just search for simple to-do list or simple to-do and HTML5 Rocks, you're going to find this demo, and it'll walk you all the way through an application, the classic to-do application that's based on indexedDB. And if I scroll to the bottom, actually before I do, I guess I'll show you just a snap of code here. We've got a little bit of feature detection, just like you did, and then we're opening a database, this to-dos database. And in this to-dos database, we're going to have this collection, and everything in indexedDB happens asynchronously. So you're really wiring up these events and saying like on upgrade needed, and on success and on error, and you utilize all of these events so that the whole thing happens asynchronously, and then you can call in create transactions like here and add to these object stores, in this case a to-do item, and you can add these custom to-do items. So at the very bottom of this tutorial, the whole thing is enabled in a example. All you have to do is type in here, let's reef the main. I'll use some sailing terms. And I've added a to-do item. Let's do one more. Let's say furl the jib. Bam, now I've got two items. These have both been stored in a database. Now, when you think database, you might be thinking there's a to-do items table with a record, with a, it doesn't work that way. It's not a relational database. This is a document database. So this is storing JavaScript documents essentially in a database format, and you can still query them, but it kind of does away with the whole concept of an SQL querying language for querying items in a database. So it's just a different way to do it. Once again, the major advantage is our ability to query and pull things out based on their attributes. So that's indexedDB, and I think you're going to take us. No, actually, the next topic is mine.
It is yours.
Yeah. So I'm going to tell you about WebSockets. WebSockets are super cool. The way they actually get implemented, this is, in my opinion, one of those things that ends up kind of feeling like magic. It's essentially replacing, where it makes sense, replacing this round-trip request-response that is natural to HTTP replacing that instead with a request, and then while the request remains open, a open license to call on the WebSocket layer, that's on the layer below HTTP, the TCP level, the ability to communicate by way of WebSockets. The huge advantage is that you do away with the overhead of the HTTP request, which can be somewhat weighty, and instead WebSocket messages have, guess how much overhead? You're on the spot.
I am on the spot. I'm going to say, on what scale?
Bytes. How many bytes?
I have no idea.
2.
2 bytes.
2 bytes.
I would have.
For every message that you send back and forth to the server by way of, well, let's say, first of all, by way of HTTP, it might be, who knows, it might be 100 bytes, or it might be, you know, a K. Might be something big like that, but for WebSockets, the only overhead you have is these 2 bytes, basically like a carriage return.
Cool.
Yeah. Yeah, so that's really great. And you can see on my screen here that the primary model of doing request response, this might take, well, this is going to take X amount of time, which might be a reasonable amount of time, like a few milliseconds, or it could be significantly longer. But with WebSockets, we have what's called a WebSocket upgrade. It's analogous to a request. And then we have the last frame, which is the end of that WebSocket upgrade. And in between, we have all these little things that are just wrapped with 2 bytes, plus, of course, the payload, the message itself. And where this starts really paying off is when you have larger messages and a lot more overhead. And you can see in these multiple use cases here, use case A, B, and C, that in some cases, it's just a little bit of a performance. Notice that the polling method, this is doing HTTP request, response, is twice as, well, that's actually quite a bit more than twice as long as the WebSocket method. But then as you utilize use cases with larger messages and such, this really adds up. You do a few calls, and pretty soon your classic polling technique is dramatically longer than your WebSocket technique. So some serious advantages in using WebSockets from a performance standpoint. Now there's a lot of good stuff available. I've got a note here at the bottom of the screen at websocket.org. So let's just actually go there together. I'm going to go to websocket.org. And here we are. WebSocket.org discusses, instructs, tells you how WebSockets work, and they also give you this echo test, which is really handy. I can go to this echo test. It confirms, hey, your browser does support WebSockets. That's good. Any cool browser does. And it has for its location this URL. Now notice this URL is preceded with WS. That's the scheme for this WebSocket, is ws://echo.websocket.org. This is a nice URL for you to remember, because if you're starting to use WebSockets and you want to do some testing, you can just use theirs. They've got a nice little echo one. Basically the way it works is you pass it a message and it passes you the message right back. So let's go ahead and try that. I'm going to connect to that, and it's going to say, all right, cool, you're connected. And then let's pass on, let's modify this and dramatically improve our message here. Let's say MVA rocks. I guess that would be like that. MVA rocks, send it, and it sends that, and also comes back with an echo, which you don't see, but comes back with the same message. Okay. Now let's go look at a special tool that I've got called Fiddler. This is Fiddler. I've got it installed on this machine. It is a client tool, and I'm going to hit F12, which is going to tell it start capturing. Now, in case you haven't used a tool like this before, if I go to the Bing homepage and wait for that to load, of course this does a request to Bing, which initiates requests for the picture of the day and all kinds of things. And actually, sometimes when you hook up something like Fiddler, the proxy gets in the way and it has issues like this. And I'm not sure. Let's try it, see if other websites work. Maybe not. Okay, let's use, all right, it's going to work with the desktop version of the browser, so let's do that. So we'll go to bing.com and then we'll jump back over to Fiddler, and you can see that we've got this original Bing request, and then we've got all these subsequent requests that came of it. That's what Fiddler does for us, is it looks for traffic like this. These icons on the left are really super handy because they tell us that this was an image or this was HTML. In this case, what's the shortcut for zoom its arrow? Is that the shift?
Oh, it's Control Shift and then use your mouse or
Control Shift. Ooh,
yeah,
there we go.
There you go.
Oops, did it backwards like you.
Exactly.
Whoa. Let's try this again. Control Shift. This one is a JSON file. So that's going to be, you know, some sort of data. So that's pretty neat. Let's actually go open that one up, and you get to see not only your request, and let's look at the request in the raw. There's the request, but also the raw response. Here's the response that it came back with, and it came back with JSON data. Mm-hmm. And Fiddler and most of the tools like it are smart enough to format that like JSON for you, so you can see it hierarchically, and you can see that this is information about this Bing image of the day. So pretty nifty the way that works.
Yeah.
That's the concept behind Fiddler. Now let's go to actually let's just go to www.websocket.org. It'll take us to that site. Let's jump over to Fiddler, and aha, it's working. It's going to websocket.org. It's all HTTP requests so far, and they're coming back with things like, here it's coming back with the actual HTML. I can tell by the icon. Here's the CSS document that it downloaded, and here's a bunch of images all over the place. Those are all images. All right, let's clear this out. I just hit clear there, and let's do this. Let's go to our echo test. Actually, now let's clear it out. And now let's connect. Bam. And it says connected. Well, what actually happened there? Notice the icon on the left side of Fiddler is a WS. It's a WebSocket icon. And this says that it's tunneling to here. And if I go look at the actual request on the right, get my touch correct there, you'll be able to see that what I've got is a WebSocket, what's called an upgrade. That's basically a request to create a persistent connection for WebSockets. Okay? So that was done, and now it's sitting there open right now. This HTTP connection is open and waiting for me to communicate on it. So now let me go ahead and send this message, and I don't see any more HTTP messages. So it's what you don't see here that's magical. You don't have another HTTP request and response happening. It's all still happening through that channel that's already open for us. It's beautiful, right?
Yes.
It's beautiful. Now, one of the cool things that you can do is go to this Demos on the Web, and there are a number of these. In fact, I encourage you all to follow along with me to this one called Rump Troll. We'll go to the original link. Michael, you need to do that too. Go to rumptroll.com. Don't forget the E. RUMPETROLL. I'm going to use the arrow keys on my keyboard, and I'm moving around. There we go. We've got folks on the call that are jumping into here, and everybody is showing up as characters in this same kind of virtual landscape. And all the communications, while we're doing this, let me go clear my, clear this, refresh Rump Troll for myself, and let's all together look at my Fiddler and notice what sort of communication is or is not going on. I've got for myself a WebSocket there, and although I'm getting all kinds of, look at all the people here. Everybody's popping into Rump Troll now, and there are no more HTTP requests getting all of this information, which means that it's going to be able to be really fast, really responsive. It's pretty impressive. Look at all those.
Yeah, and you've created a demo that by nothing happening, you succeeded. That's awesome.
Oh yeah, yeah, absolutely. I showed that it did nothing, and that was the demo, right? Okay, let me go ahead and get a screenshot of this because that's just cool.
I'm just going to continue to play.
Okay, yeah,
have
you
fun.
keep playing. Oh no, you guys need to pay attention to me. So everybody out of Rump Troll right now.
A mass exodus.
Okay, so
What is this anyway? Anyway, go ahead.
I am going to go ahead and continue. We looked at, actually, you know what? We can jump into Code Show and look at, there is a socket demo in there. There's actually two, and in the follow-up course tomorrow or the next day, we're going to be talking about WinRT sockets. They're called stream sockets. But HTML5 supports sockets, and I do a quick little demo here in CodeShow where you get to see this. Notice the HTML is insignificant. It just has an output. There's no CSS. It's just JavaScript, and this is what it takes to do a call to that exact, not rump troll, but the websocket.org that we were just at, the echo test. So I'm going into the echo.websocket.org. I'm connecting to it. Here's the opening, and then we're saying it's connected. And then the message is going to be simply WebSocket test. It's going to come back with the fact that it was sent, and that's what we end up with over here. Okay? So you can look at that. You can make some incredible games. Go for it. But we are going to move on and talk briefly about web workers and one more thing, which I forgot, but we'll get to that. Web workers. Now, remember earlier I talked about promises. We were talking about the concept of asynchrony, capturing that moment in time when something finishes so that we can do something else. Now we're talking about concurrency, perhaps also called parallelism. Okay? This is multi-threaded in nature. We are capturing the fact that most modern processors have multiple cores, and most modern operating systems are capable of utilizing these extra cores whenever we determine that something doesn't need to be on the same thread. So what we're dealing with here is kind of an alternate thread that has most but not all of what you have in the primary thread in JavaScript. Now the thing that it doesn't have is this. Notice that this is missing from down here. All right, so this is my main thread, my web page. This is JavaScript running on my page. This is a web worker. And this web worker does not have any access to the DOM at all. You can't say query selector, find me the element with ID of Fred and do something with it. You can't do that because it does not have an access to the DOM. All it really gets is what the main thread passes over to it when it creates that web worker and instantiates it. So let's see what I'm talking about. Once again, we jump back into CodeShow. We type in something like worker, and we get the web worker demo. This is actually just an image trying to relay the concept. We have the boss and the worker. Okay? Since we've got worker, I decided to make boss. So boss is what we're calling the UI thread here. Just so you know, the UI thread is not a special thread. It's just a thread. So FYI. But we have the primary thread, what we're calling the UI thread, and he is instantiating a worker. Boss is creating a worker and then sending a message to the worker, and then the worker is sending a message back in response to that one. Okay, so that's the workflow. So let's look at how this happens. Once again, the DOM is, the HTML is insignificant, the CSS is insignificant. It's all about the JavaScript here, and we have two JavaScript files. So this one is the primary JavaScript file for this demo, and this one, this task.js, is a second JavaScript file. You have to create it as a separate JavaScript file. It's a second JavaScript file that represents the worker. All right? Let's see what I'm talking about here. So we've got worker is a new worker, and here's where the JavaScript file is that I want to represent that worker. It's at demos, web worker, task.js. Now, once that's been established, I can now call that worker, and I can call onMessage. I'm not actually calling it. I'm setting the onMessage property here to a function, meaning whenever the worker sends me a message, not whenever I send the worker the message, but whenever he sends me a message, this is the method I want to run. Mm-hmm. And then I take an action here. I say, hey, worker, I'm telling you something here. I'm posting a message to my other thread. Hey there, worker. And then the worker, if we look at his thread, he is saying, he's defining an onMessage as well. So he's saying, onMessage, here's what I want to happen. So when the boss tells me something, I want to post to self. That's the way that we say, hey boss, I'm telling you something now. Mm-hmm. So I'm even including the message that was sent in to us, so it's kind of whole cycle here. You know, the boss tells the worker something, he tells the boss something back, including the message that the boss said. So hopefully this example gives you enough to get started with web workers. It's certainly not thorough, but hopefully that gives you enough to get started with web workers, okay? And then the last one I want to show you is geolocation. So this is another of the core APIs that is available to you and is super exciting because this is really neat that you as a web developer can make a website and actually find out where in the world somebody is, quite literally. Once again, it does mandate that the user agent, we're talking about the browser, never sends location information without explicit user permission per site. So just because I went to xyz.com and I said, yeah, you can have my location, doesn't mean that when I go to abc.com that it's going to be available, that it's going to be able to get my location. Okay, now whenever I get my location, this is the type of thing that comes back to me. Okay, this is a snapshot of the object that comes back to me. And it's pretty exciting because if you look at this object that comes back, it contains this coordinates. And under coordinates, I have the latitude, longitude, and that's very accurate. That's 6 decimal places. And that's really quite accurate. So it has the potential of being very accurate. Now, the individual platform and browser combination has the option of determining how accurate this is based on, you know, should I use cell triangulation, GPS, whatever. But it has the potential for being very accurate. And notice that it contains not only the latitude, longitude, but also the altitude, how the accuracy is. I believe that's in meters, so it was at 61 whenever I took this snapshot. And also the heading and the speed. So you can tell that a person's moving on the road and say, hey, you can't browse my website right now. You're going 60 miles an hour. And so I'm not going to let you use my website. That would be kind of a mean thing to do, because what if the passenger's doing in the back seat?
True.
Anyway, so that's geolocation, and you can actually interface with these. One cool way to hit all of these, besides going into something like Code Show and creating a demo, is just go to your browser and hit F12 and go to the F12 tools, and then go to the console. And in the console, you can go down and you can hit these APIs directly in the console, because everything that's available to you is available right here in the console. So there's the window object, and notice I can expand it, and I can get access to all of these APIs that we're talking about right here in the F12 console. So I guess that covers it. We can take a glance at what we covered: promises, web storage, indexedDB, WebSockets, web workers, geolocation, a whole bunch of APIs, and we're basically going to go into more APIs when we get into the next demo. Anything you want to add?
No, that was awesome.
Okay, cool. Well, that kind of wraps it. We're going to take a 10-minute break and come back for the UI APIs. Michael's going to be leading us in that one, so really hope to see you there.